Have you ever been caught in a sudden downpour? It's an experience that can be both surprising and exhilarating. One minute the sun's shining, and the next, raindrops are splattering all around you. The sky transforms so quickly, it's almost magical. Rain is a regular part of our weather, and sometimes it comes with a noisy, exciting guest, the thunderstorm. These storms can be both awe-inspiring and a little bit frightening. Thunderstorms are like the big, booming cousins of regular rainstorms. They bring a whole new level of drama to the weather scene. They bring not just rain, but also flashes of lightning and crashes of thunder that can shake the ground. The sheer power of these storms is truly something to behold, but have you ever wondered what causes these dramatic events? Let's find out! The science behind thunderstorms is as fascinating as the storms themselves. It all starts with something we see almost every day: clouds. These fluffy formations in the sky are more than just pretty shapes, but not all clouds are the same. Some are gentle and harmless, while others are the harbingers of storms. Thunderstorms come from special clouds called cumulonimbus clouds, which are towering giants in the sky, and they are the key to understanding how lightning and thunder happen. These clouds are the birthplace of the electrifying and booming phenomena we experience during a storm. Clouds form when water vapor in the air rises high up into the sky. This process begins when the sun heats up water in rivers, lakes, and oceans, causing it to evaporate and turn into water vapor. This vapor is lighter than air, so it rises up into the atmosphere. As the water vapor goes higher, it starts to cool down. The higher it goes, the cooler the air becomes, which is crucial for the next steps in cloud formation. Cool air can't hold as much water vapor as warm air, so some of the vapor turns into tiny water droplets or even ice crystals. This process is known as condensation, and it's the same reason you see water droplets on a cold glass. These tiny droplets and crystals clump together to form the clouds we see floating above us. Over time, these clusters grow larger and more visible, creating the fluffy white clouds that dot the sky. In cumulonimbus clouds, which are the thunderstorm makers, a lot of this clumping together happens. These clouds are particularly powerful and can grow to be very large. They grow tall and mighty, towering high into the sky. These clouds can reach heights of up to 12 miles, making them some of the tallest clouds in the atmosphere. Inside these giant clouds, there's a lot of movement and even some bumping and rubbing between the water droplets and ice crystals. This constant motion is a key part of the cloud's dynamic nature. This activity is important because it's what sets the stage for the creation of lightning. The friction between the particles generates electrical charges, leading to the spectacular lightning displays we often see during storms. Remember all that bumping and rubbing going on inside the cloud? It's like a giant party up there with clouds constantly moving and interacting. Well, that creates static electricity, kind of like when you rub a balloon on your hair and it makes your hair stand up. This is a fun way to see how static electricity works on a small scale. The cloud is getting charged up. It's like a battery being filled with energy, ready to release it in a spectacular way. One part of the cloud might become positively charged, while another part becomes negatively charged. This separation of charges is crucial for what happens next. When the difference in charge becomes really strong, zap, the energy needs to balance out, and it does so in a dramatic fashion. A giant spark of electricity jumps between the two areas, or even between the cloud and the ground. This is the moment we witness the incredible power of nature. That spark is what we call lightning. It's a breathtaking display of electrical energy. Lightning is incredibly hot and powerful. It can reach temperatures of around 30,000 Kelvin, which is 5 times hotter than the surface of the sun. It heats up the air around it super fast, causing the air to expand rapidly. This rapid expansion creates a shockwave. That rapid expansion is what leads to the loud sound we know as thunder. The next time you hear thunder, you'll know it's the sound of air reacting to the intense heat of lightning. Section 4. The Big Boom. How thunder happens. Imagine clapping your hands together really hard. You feel the air push against your hands, right? That's similar to what happens with thunder, but on a much larger scale. When lightning heats up the air around it, the air expands so quickly that it creates a powerful shock wave. This shock wave travels through the air as sound waves, and that's what we hear as thunder. The sound of thunder can be a loud crack or a deep rumble, depending on how far away the lightning is. If you're close to the lightning strike, the thunder will sound like a sudden sharp crack. If you're farther away, it will sound more like a low rumble. So there you have it. Thunderstorms are like amazing science experiments happening high above us. They start with water vapor, rising to form clouds, then static electricity builds up, leading to lightning strikes. Those strikes heat up the air, creating the booming sound of thunder. The next time you see a thunderstorm, remember all the amazing things happening up in the clouds. It's a powerful reminder of the incredible forces of nature that shape our world.